Hey guys, we are on Unit 8, Day 9, and we're going to talk about angle of elevation, which is looking up, and angle of depression, which is looking down. All right, in the warm-up, we have to solve for x to the nearest tenth in the following triangles. So we're going to go ahead and mark our angle x. That's where we're reading from, and 6 is the opposite. 13 is across from the right angle, so hypotenuse. Okay. Again, some old horse caught another horse, taking oats away. We can see O and H make signs. So we'll say sine theta equals O over H. Sine of my angle, which is x, equals opposite, which is 6, hypotenuse 13. Watch out, we're solving for an angle. So x equals sine inverse of 6/13. Type it in our calculator. Okay. 27.4864 ... To the nearest tenth, that's the 4, but look next door, and that's going to round it up, and we'll say 27.5. And that's an angle, so degrees. Okay. Over in our next picture, we are reading from the 37. 12 is my opposite side, and x is my adjacent side. Okay. And in this one, we're going to be using tangent. So we'll say tangent theta equals O over A. Theta is our angle of 37 degrees. Opposite is 12. Adjacent is x. We are solving for a side, so this is a cross multiply. 1 times 12 is 12, equal to x times the tangent of 37. In order to get x by itself, we're going to have to divide by the tangent of 37. All right, so that we end up with x equals 12 divided by tangent of 37. Hit enter. Should get 15.9245 ... Okay. To the nearest tenth, the 9 is not going to move, and we will say x equals 15.9. Okay, and that's not an angle, so no degree symbol. There are no units, so I just don't label it, just like they didn't label their sides. Okay. All right, guys. Coming down here, angle of elevation is an angle formed from the ground looking up to a certain point. Okay? Angle of elevation always formed with the ground, and this angle is always inside the triangle at the bottom. And that's super important right there. This angle is always inside the triangle at the bottom. So in our picture here, we have a man, and let's say he is looking straight out, and therefore this right here would be, let's say, his line of sight. That's where his eyeballs go, all right? And then all of a sudden he hears a plane up above him, and so he looks up. This right here is his angle of elevation, okay? Whatever this angle measures, that's his angle of elevation because he looked up, okay, to see the plane. Notice that angle is inside the triangle at the bottom, okay? All right, let's talk about angle of depression. That's an angle that's formed from a horizontal line of sight looking downwards to a certain point. This angle is always outside the triangle at the top. So the line of sight we're talking about now is not the little man dressed in the nice suit here. It's the pilot. Okay, so we're up here and the pilot's looking out, and that's his line of sight. All of a sudden, the pilot looks down to see the man instead of the man looking up to see the plane. The pilot looks down, and so the angle of depression is this angle right here. All right. And this is the harder one to understand because you can't use that angle when you're doing trig because it's not inside your triangle. Remember, when we use trig, we always have an angle inside the triangle. So there's one of two things that you can do to get the angle inside, and then you can use it. All right. You can realize that up here is a 90-degree angle. Okay. And that whatever this angle is, okay, that the pilot's looking down at the man at, all right, let's say it's 30 degrees. Well, you just do 90 minus 30, and now you have the remaining part of the angle inside the triangle, okay? Or what you can realize is that we have our Z shape going on, that the line of sight from the pilot and the line of sight from the man are parallel lines cut by a transversal, and we can take this angle of depression and actually put it inside of our triangle at the bottom because those are alternate interior angles, and alternate interior angles are congruent, and now we have that angle inside, and you can keep the same measure of it instead of subtracting it from 90. All right, so the angle of depression is equal to the angle of elevation, all right? But they are not the same angle. They are just congruent angles. They are in different locations, okay? Angle of depression is outside the triangle at the top, but you bring it inside the triangle because of alternate interior angles, okay? Angle of elevation, that's the easier one. It's already inside the triangle. You don't have to do anything with it, okay? So in conclusion, the angle of elevation is congruent to the angle of depression. Okay, and we're going to say because of parallel lines cut by a transversal create congruent alternate interior angles. All right, and that's the reason. So one more picture down here, okay, kind of combining the two. But think of a person at the top of the stairs and a person at the bottom of the stairs, okay? Person at the bottom of the stairs, this is their line of sight, okay? When they look up to see the person at the top of the stairs, this right here is the angle of elevation because they're looking up, okay? To elevate someone means to lift it up, okay? Like you elevate your leg, all right? If you have swollen feet, you're supposed to elevate your leg. You're supposed to lift them up, all right? The person at the top of the stairs here, person A, is looking straight out. To look down at the person at the bottom of the stairs, they have to look down that amount, okay? And because they're looking down, this is the angle of depression. All right? Those two angles have equal measures because they are alternate interior angles and the two lines of sight are parallel lines. Okay. All right. Let's go ahead and try some problems on the backside.